So we are not even going to do the first or the bottom part that you see on your notes. So just go ahead and scratch all this out because we're not going to do it. Okay? Ah, shoot. Sorry. There you go. My bad. So that whole bottom half of the page, we're not going to do it. Kind of confusing, not really relevant, not super important for you to know. So that those bottom boxes, we don't need to know. We are just going to start with what's at the top. Okay? So we need to know that distribution is the arrangement of something across Earth's surface. Keywords here, the arrangement, and across the surface. Density, on the other hand, is the frequency with which something exists. Within a given space. Okay, so there's a little bit of a difference there. The distribution is kind of like full big picture, and then density shows you like the closer up frequency of a certain space. Okay? So we're going to look at these three different densities that was kind of explained in chapter 3. I know that I was confused whenever I read it. So we're going to draw some different pictures to kind of visualize or represent those three different densities and kind of talk through the differences. We're going to use an example. We're going to use Egypt as our country example because it is a good representation of like their population numbers and shows the difference here. So if we start in our left-hand box, the arithmetic density, this is going to be calculated by the total population divided by the total land area. All right, so our visual that we're going to draw is Egypt, okay? This is my Nile River. And if we're looking at arithmetic density, the people in an arithmetic density is you're taking all the numbers of people and you're dividing it by the total land area, okay? So it's as if the people are going to be evenly distributed across the space, even though we know that that is not necessarily the case all of the time. That's why I don't like arithmetic density, is because it's not realistic. It is, you're taking all of the people, dividing it by the total land area, and that's our arithmetic density. Okay, so one dot here would be people per square kilometer. And in this case, Egypt's example, it would be 70 people per square kilometer. Okay, but do people naturally spread themselves out evenly across a space or across a country, across a state, across a neighborhood? No, they don't, right? Like people tend to go in clusters. So I don't like arithmetic density for that reason. Like it gives you a full number of people and of space, but that's not realistic, okay? Physiological density is going to be more realistic, because if you think about it, think about like just like when Frisco ISD rezones for each high school. Like if we're looking at Wakeland zone in particular, like think about all the different neighborhoods that feed into Wakeland. But if you're looking at the zone as a whole, it spreads out from like what, Main Street over to I don't even know where all Wakeland zones feed in, like the land feeds into. But if you think about it, your neighborhood is not evenly spaced out, right? Like if your neighborhood, like what's right across the street? What is it? Like Shattuck, okay? Those plots of land might be different compared to other ones, right? Like think about if you're driving towards Main Street, there's that whole field right there to the left, like towards the tollway, that's empty, right? That no houses are on. They're building those apartments there, but that's pretty empty, right? There's a field right there that they're actually starting to build a neighborhood on right there across that kind of catty corner from Target, right? But that's been an open field for forever, right? So like with those open fields, and then you have your neighborhoods, like people kind of cluster up, right? It's not evenly spread out like arithmetic density tells us it is, right? Physiological density is going to be more realistic because it's going to show us where people are naturally, or like where people are clustering up, and that gives us like a real number. Okay, so with physiological density, our what's the word I'm looking for? Equation is going to be total population divided by the arable land. Do you remember reading about arable land last week? What is arable land? Anyone? Like, not just livable, but like farmable, okay? So like you can plant crops and grow things there, and like make use of that land. So in our Egypt example here, we're still gonna go with the Nile. Okay, so this is our Nile. But think about Egypt in reality. Think about it from our first sketch map. What is in Egypt? We have the Nile, but what other big thing is there? The desert. Do people live in the desert? No. Not a whole lot, right? So in all reality, people are not living too far away from the Nile because the Nile is their only source of water, right? I think I read somewhere that only like 5% of Egypt's population lives out here in the desert. The other 95% of them is going to live in the Nile River Valley, right? Because that's where they get their water. That's how they can grow their food, is close to the Nile, okay? So in reality, our physiological density then is going to be here close to the river, because that's where they're getting, that's what's livable. That's what is like smart, what's the word I'm looking for? Profitable, I guess. Okay, so those are all of our people. So in reality, Egypt's physiological density goes way up to 3,503 people per square kilometer. Okay, so the amount of arable land is pretty small because it's just clustered near the Nile River. So if you take all of the population now and you shove it into the amount of land that is actually like farmable and can produce food for all of those people, like that number goes way up, 3,500 people in 1 square kilometer, okay, compared to the 70 if you spread them all out equally with arithmetic density, okay? Do you see that? Big difference there. Physiological is more not reliable, but real. This is reality. This is where people are living because that's where they can grow the food. It's where they can get water, right? Think about Australia. Where do people live in Australia? The coast, right? Yeah, because in the middle is all desert. And for the most part, it's all the southern part, right? Like all their big cities are on like the southern coast of Australia. Okay, so same idea there. Okay? And then our last one is a little bit different, or it's going to look a little bit different. There's not really a there's not really a formula or an equation here, but draw like a tic-tac-toe box. We're not really going to use the Nile example here. So this is a little bit different because this is the number of farmers per square kilometer. Okay, so how many farmers there are. In LDC countries, do you think there's going to be a lot of farmers or little farmers? A lot. Why?
Because it's a primary sector.
Yes, because their economic activity is going to be very primary, right? So they're going to be very involved in agriculture. So LDC countries are going to have a high number of farmers per square kilometer. MDC countries, not as much. They're going to have lower numbers. So in our Egypt case, there are 1,400 farmers per square kilometer. So lots of farmers there. Okay. So we're going to do the math part. The rest of this packet, worksheet, whatever you want to call it, is the math. Okay. So on the next page, yours is not colored like mine, but
No, I hate listening to my voice. Where did it go?
The first part is the arithmetic density, and that's all we're going to do today is just this first part. Okay. So in that top left-hand box, that arithmetic density, what is the equation that we have to follow?
Total population.
Yep, total population over total land area, okay? So the way we're going to do this is you're going to use the link that I just posted on Classroom. It's under the class resource section, it's a material thing that I posted, but it's a link to CIA Factbook. So you're going to get on CIA Factbook and we're going to look up the numbers, okay? So for the first box, the one right underneath that where it says calculate the arithmetic density, it gives us the total area, like the total land area, but we have to find the total population, okay? So if you are on Classroom, you're going to get to the CIA Factbook. You're going to have to look up the country in that little search bar, find the United States, and then there's all these different tabs, but if you click under people and society, that first part that pops up is the population, and that gives us the population number, okay? So we'll do the first one together. So the total population of the U.S. was 326, 625, 791. Okay, so that was the total population. So now what you're going to do is you're going to take those people and divide it by the total land area that's already given to you, and you're going to come up with that people per square mile number right there. You're going to do it for all 5 of those countries, and then you're going to answer the questions over there on the right side in that other blue box. I don't think yours is blue, but just answer those questions over there. You're going to kind of compare the numbers, and then that will be our stopping point for today, and then we'll come back and do the rest of it on Wednesday after our map quiz. Okay? Sound good? So make sure that you open up that link from Classroom, and that's how you're going to find your numbers. Okay, let's go over our numbers. So you were supposed to look at the CIA Factbook, right, to figure out the total population for all of these countries. Yes, so you took the total number of people and divided it by the total land area. So what was our first number that we got for the U.S.? What was our total people per square mile? 33.2. Okay, people per square mile, is that what you got? Yes, okay. For Switzerland, what was the population of Switzerland? Wake up. Last period did this to me too, and you're going to drive me crazy for the rest of the hour and a half that we have. So, speak up. What was the population for Switzerland?
8.3.
Thank you. 8 million, right?
275.
236, 303?
Yeah.
Is that what we got?
Yes.
Alex, what did you look at? Did you say that
Yeah, I looked at the world factor. That's what it said.
for the population? Did you get that number?
It's like really close to it. I got 275.
Okay, all right. So what was our people per square mile? 199. Yeah. So 200. All right. Poland's population was what? 38 million.
76,000.
269. Yep. Okay, so the math for that was 123, right? 0.05 people per square mile. China, what was China's population?
1 billion.
Billion.
379. 302,771.
Yep, 771. Okay, so that meant how many people per square mile? What was the math? 143.72. Okay, that was how many people? And then Russia?
142,000,000.
Thank you.
57,519.
519. Okay, and then the people per square mile? 8. Yep. 8.32. Okay, so if we look over at our questions on the right hand side, which country has the lowest arithmetic density? Russia, right? And which one had the highest? Switzerland. Which, is it better or worse to have a higher or lower arithmetic density?
Better to have
Yeah, better to have lower. You want it to be lower? Why?
So it's not overcrowded.
more land.
More lands, which would mean what per person? More resources, right? Yeah. Okay. So you don't want space and resources to be short. All right. A large population means a country has a high density. True or false?
False.
False. Arithmetic density is correlated to wealth and poverty. False. It's kind of irrelevant. That doesn't really matter. Arithmetic densities can help us compare the distribution of people in different countries. Yeah, true. Okay, so what does arithmetic density show us again? Equal distribution, yes, exactly. Okay, so taking all of the people, dividing it by the total area, saying that if everybody was spread out evenly, it would be this many people per square mile. Okay, is that realistic? No, why? Like arable land, right? And what else? Do people naturally spread out evenly? No. Yeah, grouped together, right? In clusters, for sure. Okay, so if we're looking at physiological density, answering this next question, I don't think that y'all did that the other day. A low or high physiological density may mean that a country has a greater ability to grow enough food to sustain its population. So switching gears here, physiological density. What was physiological density? Think back to the first page. Yeah, put it down. You need to know this.
Total population and total farmable land.
Yeah, arable land, right? Okay, so the amount of land that is able to sustain the group of people, okay? So you're looking at all of the numbers of population divided by the arable land, so the amount of land that can produce food, basically, right? The farmable land, okay? So is it better to have, or do you need a low or high physiological density to mean that there's a greater ability to grow enough food?
Low.
Why?
So there can be more food per person.
Yes, low. Low. Okay, you want it to be low. You want that number to be low because then that means that the land, you can have enough food for the people there. Because if that number is really high, then that means you're putting a really big stress on the land to feed all of those people. Okay, so that's what we're going to start looking at now is arable land. And so if we move down to that second page, or the bottom of that second page, okay, that bottom box, we're going to start with the U.S. with this question right here. So the U.S. is that big, square kilometers, and there's 16.8% of arable farmland. Remember, this is farmable, okay? How many square kilometers of arable farmland does the U.S. have? So we're trying to figure out the square kilometers of farmland. So turning this into an actual number for the U.S. So what is that equation going to be? Math people. How are we going to figure that out? Someone's going to figure it out. Who is it? How are you going to find that out?
Divide the total land by, multiply it by 16.
Multiply it. Yep. So you're multiplying these two numbers together. Okay. Multiplying those two numbers together. So do that. And what is it? Mm-hmm. 1,652,098 square kilometers. Okay, that's how much arable farmland we have in the U.S. Okay, so to do the bottom box, you're going to take the land area that is up above in that blue box up there, because it gives us the land area up here from the blue box, yes? So just copy those numbers down into this bottom green box, okay? So Switzerland's total land area was 41,277, okay? And then you're gonna go to the CIA Fact Book website again. Where is it at? Over here. Okay, you're gonna type in your country again, okay, but this time we're looking underneath the geography tab. Do you see it there? It's the second one, the geography tab. Scroll down to where it says agricultural land, and then the arable land percentage is right there, okay? So for Switzerland, it is 10.2. All right, so you're using the Factbook website to find the percent of arable land, and you're pulling the total land area from the blue box up above, okay? And then you'll do the calculations for those 4 countries. So I'll give you a few minutes to do that. It shouldn't take you long. Yes? Yes! Okay, we fixed it. Okay, good. All right, so what's our first number that we got for the answer for Switzerland? What is it? 4,210.25. Okay. Poland's total land area was 312,685. And their percent of arable land, 36. That's a large, yeah, 0.2. That's a large percentage compared to everybody else. Okay, and their number for their kilometers, 113,191.97, okay, square kilometers of arable land. China's total was what? 9,596,960, and their percentage was 11.3, okay, and that makes their square kilometers what? 1,084,456, okay, 0.48. And then Russia's land area total was the largest, 17,098,242, and their percentage was what? 7.3. That is a small number for how big their country is, okay? which gives them how many square kilometers?
1,248,171.
0.67. Okay, so I know we're doing a lot of math today, but what do these numbers of arable farmland tell us about a country?
It's a very small amount.
Yeah, it could either be a small amount or a large amount, right? If we're looking at arable land, how can we make this tie into geography and what we've talked about? How many people the land can support, right? So if we're looking at arable lands, at least in this green box, it's just telling us how big their arable land percentage is, right? If you're thinking about these countries that have a lot of people in them, you really want that arable farmland to be big, right? If they have a large population or if they're very dense, their physiological density is really like a lot. You need to make sure that you can support all of the people in your country, okay? So it all goes hand in hand. I know it's not super exciting. I know it's kind of boring because this is exactly how all of my 3B faces looked as well. But it is important, okay? You're definitely going to see this on our Unit 2 exam, and you'll most likely see it at the end of the year on the AP exam. Okay, you need to know how to calculate some of this stuff. All right, so arable land is just the farmable land. You need to make sure that you have farmable land available to support all of the people that are in your country. Okay, so let's move on to the next page. So flip it over, and we have physiological density. Okay, what was our formula for physiological density? Remember from the first page, what was it?
Total population
Over arable land. Okay, so this is really going to show us how much our arable land can support. Okay, that's what these numbers are going to be important about. All right, so for this box that you're calculating, you're given the total population and you're going to find the physiological density, okay? So take the arable land that we just found from the page before, from the green box, okay? Use the actual number, not the percentage. Use the number that we just wrote down at the end of each one of those, and that's what you're using to find these calculations, okay? I'll give you a few minutes to figure out the calculations and answer the questions on the right-hand side in the box, and then those true-false questions down at the bottom, okay? We're ready to go. Yep, there we go. Okay, what was our number that we got for the physiological density for the U.S.? What is it?
197.7.
197.7, yep. For Switzerland, it was what? 956.25? Is that right? Yeah, okay. Poland was what number? Yep, 339.92. China, what was China's? 0.88. And Russia was what? 113.97. Okay, so the lowest physiological density was which country? Russia. Because it's a large country, right, and a small population. Okay, so they don't have as many people to feed off of their arable land. Okay, so that's why it was lower for them. But in your words, what does that mean for the people in comparison to the land and the resources? Say it, Lex. You're on the right track. What was it?
They get more resources because there's less people and more
Per person, right? Yeah, more resources per person. Goodness. Okay, so the land can support more. Okay, which one had the highest physiological density? Switzerland. Is that surprising? No? Why? I was surprised. I was surprised that it was in China over Switzerland.
Yeah, Switzerland has a smaller
Yeah, so when you're looking at people and available land for farmland, Switzerland's much smaller than China, right? But they also have a lot of people. So when you're comparing people per square mile of like arable land, there's more stress on Switzerland's land than there is on China, okay? So basically, to shorten that down, there's what people compared to the land. Yeah, too many people for the resources, right? For the land to support. This leads to agricultural stress, right? Is it better or worse to have a higher or lower physiological density? Yeah, better for lower. Why?
Enough food to sustain other resources for the person.
So the land is able to support all of the people. To support the food systems and the demand of the people, right? Okay, so you want that number to be lower. When you look at MDCs and LDCs, when you're looking at farmers in that arable land, you'll have smaller amounts of farmers in MDC countries, right? Because we're more industrialized. So there's machines doing the work, right? But we still need arable land to be able to support our population, okay? But when you're looking at LDC countries, you're gonna have a lot of people involved in agriculture, right? Because they have those primary economic activities is their main source of income, right? But when LDC countries have a high physiological density, that's when that country can really struggle, right? Because that means there's a lot of people relying on a small amount of land to give them food, and that becomes a problem, okay? So your physiological density, you always want to be smaller, okay? When we're looking at these true-false questions, large population means a country has a high density, true or false? False, yeah. The physiological density is correlated to wealth and poverty.
False.
False. We don't know that. And then a low physiological density means that a country may have an easier time growing food. True. You want it to be smaller because then it's not as stressful, right, for the government, for the farmers to feed the people. Okay? Make sense? All right, you're going to scan all 3 of these pages and upload it. We found a way yesterday. When you use CamScan, scan it in and upload all 3 of those pictures to your drive, and it will download it into one PDF. So instead of uploading 3 pictures onto Padlet, it will be one PDF. So you'll scan it in on CamScan, and then you'll get all 3 of those pictures. I think you click on them to get a little check mark on each picture, and then when you click share, and you share it to your drive, it will upload it in one PDF. Okay, so that's how that will be the thing that you put on your Padlet.